Hi everyone, welcome to Dataverse Academy. In this video, we will learn about entity relationship diagram. Many of you studied in a college, specialized different faculties as engineering, law, social sciences, and also registered multiple courses during different semester. And each time when you enroll for a new course, the relevant information about you as a student and related courses is inserted into school database as a new transaction. In general, a database is an organized collection of data, so you can organize data into tables, rows, columns to make it easier to find corresponding information. So in here, student, faculty, and course information are the main elements of this database. But data modelers need a visual way to understand how these different elements of database interact or relate to each other. So to show this, we need entity relationship diagram. An entity relationship diagram is a visual representation of different entities within a system and how they relate to each other. In other words, ER diagram help to explain the logical structure of databases. But when do we draw ERDs? While ER models are most developed for designing relational databases in terms of visualization and physical database design, there's still other situation when ER diagrams can help us. Here are some typical use cases we can mention about. In social engineering, an ER diagram is often an initial step in collecting requirements for an IT project. It is like a blueprint of a database that allows us to draw a database design. It is also an easy to use graphical tool for data modeling, which helps to describe entities, attributes, and relationship. On the other hand, we can convert EI diagrams into relationship tables, which allow you to build database quickly. And with the help of it, the database designer gains a better understanding of the information to be contained in the database. So ER diagrams are created based on three basic concepts: entities, attributes, and relationship. In a typical ER diagram, you can find three symbols such as rectangles to represent entities, ovals to define attributes, and diamond shapes represent relationships. So let's have a look a little bit detail of these objects. Entities are the basic object of ERDs. We can assume them as nouns. For example, students, courses, employees, projects, faculty are all main components of ER diagram. When we consider the database, entities are converted to physical tables. When we look at the following diagram, as you can see that we have three entities: student, faculty, and course. So let's talk about relationship that exist between these entities. So relationship describe how these entities will interact with each other. When you look at the orange shape, that shows the relationship between these entities. We can think also relationship as verbs. For example, student enrolled in a course and the relationship described the act of enrolling. So in our example, student study in a faculty and faculty provides different courses and student enroll to different kind of courses. So these are all the relationship between these relevant entities. So now we have our relationship in place, and you have noticed some characters over there as M, N, and 1. Relationships are described with cardinality. So it means The cardinality defines the possible number of occurrences in one entity, which is associated with the number of occurrences in another entity. So it seems a little bit confusing, but we are going to understand it better with some detailed example. So three common use cardinality relationship are one to one, one to many, and many to many. So let's look at them in a detail. We are going to start with many to one or one to many relationship. As we already have some relevant scenarios exist in our presentation, you can see the cardinality between student and faculty is many to one. That means faculty can have many students. However, a student cannot study in different faculties. For example, a student cannot study in both engineering and law at the same time. Therefore, a student side has many occurrences. It represents with the letter of M. Against this, the faculty is defined as 1. Or another sample, and faculty could have many courses. For example, engineering faculty could have mathematics, physics, and chemistry. That is why courses sites represent as M. But a specific course like chemistry cannot belong to both engineering law faculties at the same time. That is why it is represented as one side. Think a little bit out of the box. A customer can be placed many orders, but a specific order cannot be placed by many customer. Now let's look at the many to many relationship. Many rows of first table associated with many rows of second table. For example, the relationship between student and the course table is many to many because a student can take many courses at the same time and a specific course can be assigned to many students. And the last one is one to one relationship. Theoretically, when a single instant of an entity is associated with a single instant of another entity, that is called one to one relationship. For example, a person has only one passport and a passport is given to only one person. So the relationship always one to one. And the last green boxes shows the attributes. Attributes are facts or description of entities. For example, student first name, last name or faculty name, course name are all descriptive characteristics of relevant entities of student, faculty and course. Remember, each entity in your diagram represent a table within your database, and attributes are description of entities and they become the column of these tables on the database. An attribute has a name that describes the property, and the type of that describes what kind of attribute it is, such as varchar for a string, int for an integer. When an ERD is drawn for a physical database development, it's important to ensure the use of data types that are supported by the target relationship database management system. Additionally, attributes will take place in different functionalities, and we are going to focus on the most critical ones. Primary key is an attribute or sometimes set of attributes that uniquely identified every record in a certain table. So for the student table, which is based on the student entity, the primary key is going to be a value that makes this student is unlike any other student in our table. There are few rules we need to consider in order to qualify an attribute as a primary key. So primary key has to be unique. It needs to be never changing. And finally, primary key needs to be never null. So let's look at a specific customer like Jim Black in here and determine what data might be uniquely identified him. So you can't rely on the names because two totally different customer could very easily share the same first name and last name. So that leaves us with the customer ID. By design, any sort of IDs is typically programmed to increment for each addition to the table. Jim's customer ID will completely identify him as a particular instant in our database, and that value won't be repeated in this table. So let's think about some real example that we can encounter every day. So have you ever tried to create a username for a website or email account and then later wanted to change it to something else because it was not easy to remember? But then you can't change because the website doesn't allow you. The reason behind is probably your username is being used as a primary key in the database of this website because a primary key can never change. They don't like to change it because their system relies on a primary key for accurate records. Or how about when you're setting a new account and you try to create a username but get an error message saying that it is already taken? Again, this could be happening because the username is being used as a primary key and primary key cannot be repeated. And second critical attribute for us is the foreign key. So foreign keys, sometimes we call it as reference key, is used to link two tables together. So typically you can take the primary key field from one table and insert it into the other table where it becomes a foreign key. So note that foreign key is not needed to be unique. Multiple records can share the same value. If you look at the specific student, it is a faculty ID of E001. This is a foreign key because it references the primary key in the faculty table. So now we know exactly which student in which specific faculty. The same faculty ID is repeated because more than one student can study in the same faculty. And unlike primary key, foreign keys don't have to be unique. They can be repeated in a table. And another difference between primary key and foreign key is that there can be multiple foreign keys in one entity. You can convert your ER diagram to relational data model by using any of the data modeling tool. It can be either Irwin, InfoSphere, IBM Architect, or any other data modeling tool. That's it in this video. In the next video, we will learn about conceptual, logical, and physical data model. Thank you for watching this video.